Hello everyone. In this video, we are going to deal with the concept of the producer and then consumer problem using the sleep and then wake up mechanism. Before getting into this actual meaning of the sleep and then wake up mechanism using of this inter-process communication scenario, we are giving a two issue busy waiting problem as well as the priority inversion. When coming for this busy waiting problem, you people already know that what is the meaning of critical region. Whenever we are talking about this inter-process communication, we will be giving a common space or maybe the common resource for the two process. So how this common things can be shared between the two processes matters. So in this scenario, we are saying this critical region as a common space. So in this critical region, definitely we have to allow a single process to make use of this critical region. The other process definitely will be in the outsiders of the critical region. We cannot give the privilege for the other process. So in this scenario, just imagine process A in the critical region, process B is outside the critical region, but the process B doesn't know at which time it's going to get into the critical region because there is no time limit has been given by the process A. I mean, which time they have to enter in this critical region. So in this gap, I mean in this period, definitely the waste of CPU time is a lot. Okay, so I mean this is the period we are saying as in busy waiting. So this scenario will be called it as in busy waiting problem. Second, we are coming with a priority inversion. Again, you can imagine you are having a two process. The one is high priority H and the another one is L, low priority. For example, the low priority having the privilege to execute in the critical section, they keep on doing their work, but at the same time, the H of the higher priority is running in the outside mode. Usually, the higher priority definitely should have the chance to get into the critical region because that is the main reason we are giving the priority as high. But still from the outside of the critical region, the H is blocking the L. So obviously the L doesn't know how to exit from there. Okay, so this is one sort of blocking from the H because of the higher priority, the H is blocking the L. So L is doesn't know how to come out of the situation. At this scenario, both the H and the L will be in a stuck mode. It is called it as in priority inversion. So whenever you are dealing with this inter-process communication, especially we have come across the strict alternation, disabling of all interrupts, and then lock and then key mode. So everything to make this inter-process communications in an effective way. Then I mean after come across this Peterson solutions using of this hardware, these are all the crucial issues we are facing. The anyway the IPC is going to work fine using of this Peterson solution, using the TSL concept, and then exchanging of your registers, and then log key using of XCHG concept. So it's going to work fine, but still again we are having this two issue using of this Peterson solutions as well as the some of the algorithm we have come across. Busy waiting problem and then priority inversion is the two issue we are facing of. So to avoid this two issue only, we are going to make use of this mechanism of sleep and then wake up. Okay, so how the sleep and wake up are going to address this issue? So whenever we are talking about the sleep and then wake up, the sleep is nothing but a process A is enter into the critical region. So the process A is automatically work into that, and then process B is waiting at the outside. So the waiting process will be put up in the sleep mode. Okay, maybe we can say it is in suspended mode. So in this suspended mode, obviously the outside the process B will be in suspended mode without consuming any other CPU time. So until the waking process, the process B will be in a sleep mode. Another thing, we are having a wake up call. So this is the wake up call we are having. So in this wake up call, so a process after finishing of the process A, it's going to call the process B as a wake up call. So this process B will get into the normal state. After the suspended state, it will get into the normal state where it is was stopped, or maybe where it is was suspended. So automatically it's going to resume this activity. So using of this sleep and then wake up, definitely your CPU waiting time will be reduce. Reduce means the complete CPU time will not be utilized. Anonymously. This is the main idea we are coming with the sleep. Okay, because the process B, there is no need to check the critical region to make sure their chance or not, or their turn or not. So when the turn is there, automatically the completed process is going to wake up them. So until the another process will be put up in the sleep mode. So in this way only the sleep and then wake up process is going to address these issues. So that's what I said. Using of the sleep and then wake up, definitely the no busy waiting. The busy waiting process will be vanished. And then again the solving priority of inversion, nothing but the, even though if the low priority process is getting into the critical region, the higher priority process can take up the scheduling can take up the scheduling of the critical region to run their execution. So in the meantime, this lower priority of L process will be put up in suspend mode for the temporary. So after completion of the higher priority, the lower priority can get the chance. Okay. So apart from blocking this lower priority, so we are making this sleep and then wake up mode based on the priority. So this is called it as an priority inversion can be solved using of this sleep and then wake up scenario. Okay, so using of this sleep and then wake up mechanism, we are having another sort of example, producer and then consumer problem. This producer and consumer problem can be said as an bounded buffer problem. In the earlier stage, we will be saying as an we are saying as a bounded buffer problem. Here, we are having two process, the producer as well as the consumer. So this producer and then consumer going to share a common area. Here this common area is nothing but we are saying as in buffer. The fixed size buffer can be shared between the producer and then consumer. Okay, so here the producer, the what is the job of the producer is nothing but the producer is going to add the item in the buffer. If the buffer is full, the producer cannot able to add the more items into the buffer. So until that, producer will be keep on into the sleep mode until the consumer removes some of the items from the buffer. This is the task of the producer, and then we can come for the consumer. So consumer is nothing but he is going to remove the information, item from the buffer. So continuously a consumer can take the items from the buffer. If the buffer is empty, the consumer cannot take any items from the buffer. So until the producer puts some of the items in the buffer, the consumer can be put up in the sleep mode. So this is the scenario of the producer and then consumer problem, because this is the way the interprocess communication is going to work, because we are sharing the common resource. Here the common resource is nothing but we are saying the fixed size buffer is the common resource here. And then to activate this producer and then consumer problem, we are activating this sleep and then wake up scenario to move it in a very smooth way without having any other issues. Okay, so this is a problem we are going to see in graphical mode how this problem is going to work on. The left hand side we are having this producer. Okay, so whenever I'm clicking this, okay, the producer is going to add on some items in this buffer. Okay, the center point is the buffer. So here we are having this fixed buffer, right? 1 2 3 4 5. So 5 items we can feed here for now. So here first item is filled, the producer is producing second item, and then the producer is going to produce the third item, and then fourth item is filled, and then fifth item is filled. Okay, and then if the producer accessing the third next one, they saying this, the buffer is full, so the producer cannot fill any more item in this buffer because the buffer is full. So here we can talk about the consumer. So the right hand side, the consumer will be there. Okay, so the consumer is going to fill up the get the informations one by one. So the first item is removed, the second item is removed, the third item is removed, and then the fourth one is removed, and then fifth one is removed. Okay, again if I'm trying this, but obviously saying this, the buffer is empty. The scenario is the producer cannot fill item if the buffer is full, and then the consumer cannot take any item if the buffer is empty. Okay, and also we have to know that in case if I'm having a single space in this producer, definitely the producer can have the chance to fill it. At the same time, if the consumer, maybe if it is having a single item in this in single item in this buffer, so consumer can have the chance to take the item. Only thing is minimum level of space should be, I mean, at least one space should be there for the producer, and then at least one item should be there for the consumer. This is a scenario. If the buffer is full, the producer cannot take it, I mean cannot fill it. If the buffer is empty, the consumer cannot take any item. So this is the concept of this producer and the consumer problem. So here how the sleep and then wake up mechanism is going to work it out, we can see that in the next slides. Okay, this is the overall algorithm for your producer and the consumer problem. Let's see that here we are having this hash define n equal to 100. In the previous slide, we have given as buffer size as 5. So here the buffer size we can make sure as 100. And then we are having count equal to 0. I mean initial count will be 0. We are having two procedures, void producer as well as the consumer. We are having two things. So this function is going to work by the producer, and then this function is going to work by the consumer. At the initial stage, you are declaring the variable for your item, and then the entire code will be there using of your while statement. The thing is it's going to repeat forever. Okay, and then your produce item, because the producer is going to produce some item, so this method is going to be called, and then we are feed the information in this item, and then we are checking one of the if condition, if count equal to n, and then we are putting this producer in the sleep mode. Why means, because I already said that if the buffer is full, so how you are going to check this buffer is full, because count at the initial stage we are producing as 0, and then n is nothing but the total number of items we are going to feed, because the total number of slots in the buffer. Okay, if the count and then buffer n is equal to in the same count, obviously we are setting the producer in a sleep mode, and then we are having the after that sleep mode, until the wake up mode, the producer cannot get back here. Okay, so in case if I'm having some number of slots in that, in case if I'm having number of slots here, obviously this insert item method will be called to insert item in the buffer, and then we are counting increase the count of your count variable, and then if the count is equal to 1. Okay, so I mean I already said in the previous slide, even the consumer can have the chance, if it is having a single item, at least single item in the buffer, the consumer can have the chance for waking up. Okay, so if count is equal to 1, definitely we are going to wake up the consumer. Okay, this is the process of the producer. Then next we can come for the consumer. So the same way we are declaring the variable of item, the entire while loop will be run forever. The very first thing we are going to check, if count is equal to 0, I mean no other items in this buffer, means definitely the consumer will be keep into the sleep mode. And then if it is not, means I mean if some of items are there in the buffer, automatically it will get into the remove item of, okay, remove item of there. So remove means we are pulling back one items one by one, and then we are feed the informations in the item. After pulling back the item, definitely your count will be reduced, and then at which point we are going to wake up the producer. At least I'm having of single space in the buffer, count equal to n minus 1. At least I'm having of single space in this buffer, automatically I can wake up the producer. The final informations will be, I mean, showed up here. This is the scenario of the producer as well as for the consumer. I mean, this is the way we are, I mean, the entire program is going to work it out. The using of this sleep and then wake up problem, your producer consumer problem is going to work it out. The simple thing, the producer sleeps if the buffer is full, count equal to n, and then consumer sleeps if the buffer is empty. So this is the scenario we are using of this flag item sleep and then wake up. I mean automatically make a particular process in a sleep mode, and then automatically we can wake a particular process into the wake up mode to continue their work. So each process will wake the other when the conditions are low. So if the conditions, I mean, in the previous slide we have seen with the several conditions, no, in case if the producer is having a single slot, the consumer can wake up. If the consumer can have a single item, the producer can wake up the consumer. So this is the scenario can be done vice versa. Okay, at which point we can face this race condition? Hope you people know what is the meaning of race condition. Here, in the product producer and then consumer, definitely we will be coming under the issue of race condition. So before that, or we should know what is the meaning of race condition. If any one of the shared or maybe the common things is going to be updated anonymously by any of the process is utilizing. For example, process A and then B is there. If process A have the chance to modify the informations of the common shared memory which is put up by the process B, definitely we cannot have the integrity of the informations of the shared information. So at this point, definitely we will be facing the concept of race condition. So in this producer and then consumer also, we are having the same sort of issue. The consumer checks the count. They checks the count. If it is fine 0, so it will go to the sleep. So this is the first scenario. They are saying at the initial stage, the consumer is checking. I mean, there is no other item in the buffer. So automatically the consumer is going to the sleep mode. Then the producer is running into the critical region. Automatically it will increment T count by adding this item. So the count will be become 1. So what the producer may say as in the discussion, so at least one item is there. So automatically it's going to wake up the consumer. So the same way the producer is waking up the consumer since the count was 0 because the consumer is sleeping and the calls wake up on the consumer. Okay, however the consumer is not actually sleeping yet, so the wake up signals get lost. Actual scenario, the producer is waking up the consumer, but still if the consumer is sleeping, automatically the communication can be passed. In case if the consumer is not at all sleep, okay, consumer is not slept anywhere, it's already in a waking mode, so definitely this wake up signal will be get lost. That is the issue. If the wake up signal is get lost, the consumer cannot get the wake up call anymore. The same way producer cannot get the information from the consumer. So both the consumer and then producer will be getting to the prolonged mode of waiting list. So it can be lead into the deadlock also. So this is the issue if we are saying we are coming under the race condition issue, because race condition is nothing but data integrity. If you are losing the data integrity or maybe the situations getting into the deadlock situations, everything will be coming under race conditions. So in case if you are lost the wake up signal, definitely we will be in a crucial period. So here the consumer lost the wake up signal. Definitely both the producer and then consumer will sleep forever without having any other process to be done. So how we are going to deal with this issue? Okay, so to deal with this, we are having the wake up waiting bit. Okay, so in case the consumer is in a waking up mode, okay, automatically it's maybe there is a chance to lost this waking up call. So for this we are having a waking up waiting bit will be there. Using of this waiting bit, every time when the producer is send a waking up signal, it will be stored in the wake up waiting bit. Okay, whenever the consumer is awake, the wake up signal is stored into the bit. Okay, whenever the consumer is getting attempt to go to sleep, whenever it's having a thought to sleep, it's going to check for the waiting bit. Okay, if it is in alarm mode, if it is set that there is some of the product is there, you can wake up by the this information has been passed by the producer, means the consumer definitely go into the process apart from this sleeping mode. What are the missing informations is there, everything will be fed within this wake up waiting bit. So no other communication has been lost using of this wake up waiting bit. Okay, so whenever the producer is sending wake up call to the consumer, if it is missed, means obviously it will be feed in this wake up waiting bit. So this consumer definitely have the chance to revise it, I mean to revisit it. So revisit whether it is any information is there, any information is backlogged in this waking up waiting bit. So it's going to recheck it. According to this, either they have to reset, they will be in a sleeping mode, or maybe into the process. If any information is there in the wake up waiting bit, obviously without sleeping mode it will get into the process. So every time is going to clears this waking up waiting bit. So in this scenario, definitely this wake up waiting bit is going to be the helpful to reduce this race condition process in this producer and the consumer problem. Okay, so after all those step by step issues we are overcoming one by one, but still we are saying that this problem will be exist in a complex cases, because the previous scenario we have deal with a single process. In case if multiple process or there, if you are dealing with the multiple producers and then multiple consumers, means definitely we cannot stick on with this one waiting bit. Definitely we have to make use of multiple multiple waiting bit as a wake up call, as well as we should have a multiple conditions to work this problem in a synchronized way. So this is the only solutions we can come up for now. Okay, so these are all the things we have learned so far about this producer and then consumer problem using of sleep and then wake up mechanism. Hope you all learn correctly. Thank you.